Hi guys, hope you are doing well and enjoy the blessing of God. So in this video, we'll learn about the simulation of basically DFT simulation of small structure on Material Studio. So first of all, open Material Studio. I have Material Studio 2017. So I open it. So in last video, I guide about the basic graphic user interface of Material Studio. So in this tutorial, we simulate a small structure like carbon, benzene, phenol, or other organic or inorganic compound structure. So create a new project here. You save it in your default folder when what you want. So I give him name tutorial 2. So tutorial 2 is okay. So this mean it builds a complete folder of this whole file, like you simulate more than one structure, so all the structures are available in this file, and this file is saved in your default folder what you set. And also start from the blank simulation. Here you see this is our new environment. So open 3D automatic document. Here 3D automatic mean we built a 3D structure here. So you see that different options are available now to simulate our first simulation of our small structure. So here uh, I take a ring-like structure that is most probably benzene ring, but we don't have a double bond on corresponding. So first of all, to build a complete benzene molecule, we select 6 rings that tells us about their 6 carbon attached in the ring form. So next, we need to build a double bond. So click on the center of that 2 carbon. So you see that option is open. Here we develop a double bond, and similarly at this location, uh, click in center and double bond, and then the last one double bond on that side. So now we change the color and structure design of using this setting. Display style, we choose ball and stick most probably for our A's. So you see that now remaining hydrogen we attach using auto hydrogen. So here we have auto update hydrogen. So we simply click. You see that on vacant spaces automatically the hydrogen atoms are attached. So by rotating, we confirm it. We develop C6H6 complete benzene ring structure here. So now we move towards simulate to calculate our density of states, our energies, and our HOMO and LOMO and other useful properties for our further study molecular level chemistry of that molecule. So I use here DMol3. You see there are various types of simulation tools. So I use DMol3. Go to calculation. Here first we optimize geometry. So click on geometry optimization. Here we choose this setting, most probably PBE, and you want if spin unrestricted, you check this. In this case I don't, so to check this spin unrestricted, so you go to the mode section. Here you see the energy value, the maximum force and displacement. You change it by yourself. Here we have maximum 50 iterations. We change it like 999 here because shortage of our time. So I put here 100 iterations here, and then we go towards here you see the quality of this. I put a fine quality, and you see that the values of energies automatically change, and also maximum force as well. So here you see 4 steps. So we firstly set up our setup, and then we go towards electronic properties. Here again we select fine. SCF tolerance we put here medium. Here you see DFT semi-core pseudo port. So you click here for DFT. Here you have a DND. I select DNP, most common methodology here. So basic file is 3.5 or 4.4. I select default 3.5. And if you study the process in any solvent, so you choose here solvent solvation model here. So in these properties, before going towards properties, you see here we have a option, another option. So here again ask about the SCF tolerance cycles. Here I again put cycles 100 because we have 100 iterations. If you have a small bigger size molecule, you use simmering as well, because without simmering your simulation is not completely done. So here we have these type of options, and then orbital cutoff we use custom. Most commonly we use 4.6 and click assign. Then here we have a Cosmo setup for our solvent. So here we have a variety of solvent. In this simulation, I use water as a solvent, and then you simply cancel out, the setting remains same. So after that you see that our property section here, they ask about what type of properties you calculate. So in this simulation we calculate density of state, electron density, electrostatics, we calculate population analysis. Population analysis is helpful for calculating molecular charges, that means the charge on each atom. So here we have optic study and orbital. So orbital tell us about HOMO and LOMO. So I think these 5 properties are enough for this simulation. So now we move toward job control. Here you have see there are 8 cores in my system. So here you see 8 cores, and depends upon how much core you have or how much hard you have. So I here give my maximum memory of 4000. Here I give them 4 core, and here you also name the component you simulate. So here I simulate benzene, so I type here benzene. So after completion of this setup, you simply click on run. Check simulation is now ready to start. After starting, it evaluate different type of results step by step for us. So here you see the simulation is running in very effective way. So in this step we optimize our structure of benzene. Here you see we have a energy calculation graph here. Also you see here we have a convergence that change with respect to running. Here we have our results that is finalized after completion of simulation. Here we have a structure of optimized geometry that simulate in this process. You see here a complete simulation is completed. So after that you need to go to the structure, remain the other data same, and you just move towards selection the structure from here, that is geometry optimized. Go to the DMol3 and calculation. Here you just change geometry optimization to energy optimization. It helps to further optimize your energy of that type of structure. So again click on run, remain the other settings same. So you see that here simulation for energy optimization is started. So here you see that energy optimization is also completed. So click here OK. So we calculate and evaluate our results from here. Here you first go towards the status of the benzene ring of geometry optimization structure. So here you see we have a result sheet that is in the form of notepad. Here you see a complete guidance and data of our benzene structure simulation. So if you go in the bottom of the simulation, you see the different type of results here. So you see a Fermi energy here, molecular charges is here. So also we have a rotational elemental data here as well. So here you see total energy that benzene ring have minus 232.029. So from here we calculate our energy that is in heart rate. So if you want to in EV or kilocalorie per mole, you change it using calculator or unit converter. So then we go towards a benzene result simulation. This is basically energy simulation results. So now we have here, if we close the energy folder, we have a geometry optimization result. So here when you go towards bottom, or the shortcut key is simply press Ctrl F and type successfully. So here you see our simulation is finished. So again we have a Fermi and optimized energy also here. You see a total energy and total energy with factor, dielectric solvent energy as well. So if you calculate HOMO and LOMO, simply press Ctrl F and type HOMO. Find no. That's mean it is in the energy simulation, or somehow it is missed during evaluation. So here we have final HOMO and LOMO value in energy calculation. You see, if I cancel out this, so in you see that this is our final higher atomic occupied molecular orbital value, and here we have a lowest unoccupied molecular orbital value HOMO LOMO. So for geometry optimization we calculate our energy, and further energy optimization we optimize our energy as well. Along with that we calculate our HOMO and LOMO of our benzene molecule. So hope so you find these results very realistic and helpful for you. And this simulation also base level simulation, so this will very helpful in your research and your study to study the molecular level chemistry of the molecules. So here one thing that you see, we have a sigma profile. Sigma profile also valuable thing that tell us about charge density, how it's variate between this plus 0.0082 minus 0.008. So this is a variation And in next video, hope so we calculate density of states and also some other properties that are very helpful in our calculation.